So this is in the three cases determine 0 in a general manner. Row or column is referred as a line or vector. Next property is, if two parallel lines of a determinant, say delta, are interchanged, then determinant retain its numerical value but changes in sign. That means whenever R1 interchanges to R2, two columns interchange, then your determinant value is unchanged but numerically unchanged but changes in sign. Plus goes to minus, minus goes to plus. In general, so interchanging of two rows, two columns means one row is passed over another row, one column is passed over another column. Okay. In general, if a line means row or column, be passed over m parallel lines, that means we have done that operation, interchanging of two rows, two columns m times. Okay. Then the resulting determinant is nothing but minus 1 raised to m into delta, where delta is the initial value determinant. Initial determinant value, better to write initial determinant value. See, delta is nothing but given determinant, say some 2. If you interchange two rows, you will get answer is 2 but with opposite sign, minus 2. If you interchange second time also two rows, two columns, you will get 2 minus pre-multiplies becomes plus. Like that, if you interchange m rows, m times, interchanging of two rows, two columns m times, that initial determinant value pre-multiplied by minus 1 raised to m. That is called passed over m parallel lines. Okay. The next one is, I don't remember the point 5 or 6th one. If each element of a determinant is multiplied by the same factor then the whole determinant is multiplied by that factor. First, write this point. I will explain the above points with some examples. Just see. Let delta is equal to 1, 2, 3, 4. What is this value? 4 minus 6 minus 2. Okay. Now I am applying 2R1. R1 interchanges to 2R1. Okay. So this becomes delta. That means R1 is every element of first row multiplied by 2. 2, 4, 3, 4. Let us say delta dash. This is the new determinant obtained by multiplying the first row with 2. Now what is the answer for this delta dash? 2 into 4, 8 minus 12 minus 4. Now what I told? Then the whole determinant is multiplied by that factor. That is minus 2. This is the whole determinant multiplied by that factor. That means this can be written as minus 2 into delta. So therefore delta is equal to minus 1 by 2 into delta dash. That means whenever you are applying a row with 2R1 or multiplication of a row or a column by a number, then in the final answer you should divide that number so that the determinant is unchanged. That means the whole determinant is multiplied by that factor, means originally the determinant we got minus 2. The whole determinant is, the given determinant is multiplied by that factor. Okay. Now see another example. Determinant 1, 2, 2, 4. What is this answer? 0. Why? Since R2 is equal to 2 into R1. What I give? Ri is equal to K into Rj. Ca is equal to K into Cj. Like that. Next, whenever 1, 1, 2, 2. Just see. 1, 2, 3, 1, 2, 3, 2, 4, 5. Now what is the value? Here two rows are identical. First row, second row. Now just expand using determinant procedure. Selecting by first row, verifying the properties only. 1 into 10 minus 12 minus 2. This 2 into minus 2 into, leaving second column first row, 5 minus 6 minus 1. The last element 3 into, using determinant procedure, 4 minus 4. 0. Now what we got here? 0. Whenever two rows, two columns same, determinant 0. Whenever in a determinant a row is equal to number into another row, similarly column is equal to a number into another column, then determinant is equal to 0. Next. So here earlier we got delta is equal to minus 2. Okay. Just I am verifying with a 2 by 2 determinant procedure. Similarly it is true for any order. If I apply R1 interchanges to R2, so then you will be getting a determinant interchanging 3, 4, that is 1, 2. Let us say a new determinant delta dash. Say. Now what is delta dash value? 3 into 2, 6 minus 4 is equal to. What I told? Numerically 2, 2 same, but changes in sign. Okay. So once you apply an operation, you will be getting a new determinant that is denoted by delta dash. Initial determinant value denoted by delta. Just find or check the relation between these things with the above properties. Okay. Similarly, in a determinant, if a row is completely zeros or a column is completely zeros, then the determinant value is also 0. Just I will do one example. This is given 2009 2 marks. If m is equal to 3 upon 5, 4 upon 5, x 3 upon 5, that is 3 by 4, comma, m transpose is equal to m inverse, then the value of x, question mark. Solution C. Now m transpose is equal to m inverse, I already given in the definitions previously. Orthogonal matrix A into A transpose is equal to I. Alternative definition I have given, transpose is equal to inverse. Refer that definition. That means m is orthogonal matrix, which implies, use your alternative definition, m into m transpose is equal to I. I means corresponding 2 by 2 identity matrix, which implies what is m? 3 by 5, 4 by 5, x 3 by 5 into its transpose 3 by 5, x 4 by 5, 3 by 5 is equal to what is corresponding identity elements? 1 0 0 1. Now here first row into first column, no use multiplication, because we are going to find x value. Just first row multiplied by with second column and then equated to the corresponding element in the right side, which implies 3 by 5 into x plus 4 by 5 into 3 by 5. What is the corresponding element there? 0. That means I am not doing complete matrix multiplication, because we are going to find one unknown x. So wherever it is necessary, that is first row into first column or first row into second column, use that only and equate the corresponding element in the right side. There you save the time, okay, number of steps also, which implies x is equal to minus 4 by 5. 3 by 5 is a non-zero number which is common, send into right side. The other example is, which is given 2005. Let A is equal to 2 minus 0.103 and A inverse is equal to 1 by 2 A 0 B. Then A plus B is equal to, just I am doing here. Solution. A is given and its inverse is given, but we have to find the two unknowns A and B and then their addition, sum. So we know the well known property between these two, A into A inverse is equal to I. Since A into A inverse is equal to I, which is not given actually, that is automatically true, okay, satisfies. That means 2 minus 0.103 multiplied by 1 by 2 A 0 B. What is the corresponding 2 by 2 identity matrix? 1 0 0 1. Now here first row first column I am not multiplying, because we are not getting anything A B. So I want to go for first row multiplied with second column. 2A, not required in sometimes all the rows and columns multiplications, generally matrix multiplication, okay, wherever it is necessary go by that procedure, okay. 2A minus 0.1 into B, that means I have done first row multiplied by second column, that is the second element in the right side, which is nothing but 0. Equation 1, we are not getting anything here. Similarly, multiplied the second row of pre-matrix with the second column, you will be getting 0 into A, that means 0A plus 3 times B. What is the last element? Second row into second column means last Last element in the right side is 1. From this we are getting b is equal to 1 upon 3, that is 1 by 3. So therefore 1 implies, simplifying 1, 2a minus 0.1 by 3 is equal to 0. That means a is equal to 0 point means 1 by 10, 1 by 30, that means this becomes 1 by 60. Therefore a plus b, 1 by 60 plus 1 by 3, LCM is 60, 1 plus 20, that is 21 by 60, which simplifies to 7 by 20. Later you check this is correct or not. Sometimes everyone doing silly mistakes only, okay, addition, subtractions, you please later check. So third one I already show how to find A inverse, later you do. Which is given 1994, the inverse of the matrix 101 minus 1 1 1 0 1 0. So I am giving the answer because I already proved, I already shown the procedure for finding A inverse. Minus 1 by 2, myself also sometimes I may do mistakes, small mistakes, you please check this is correct or not. Minus 1 1 minus 1, later, not now, 0 0 minus 2 minus 1 minus 1 1. So here itself I can check, first row first column, minus 1 minus 1 minus 2 into, okay. So 2 more problems on basics, after that we will go to rank of a matrix. Fourth one. Given, this is given 2006, 2 marks, get E into F is equal to G. Product of E and F is G matrix, where E is equal to cos theta minus sin theta 0, sin theta cos theta 0, 0 0 1. And G is equal to the corresponding 3 by 3 identity matrix. Then F is equal to question mark. See, what is E here? Cos theta minus sin theta 0, sin theta cos theta 0, 0 0 1. Just I am giving an indication. These 4 elements which is I already given 2 by 2 well known orthogonal matrix. Okay, these are third row, third column identity matrix. Generally by hit and trial, okay, method we can say this is orthogonal matrix. Or you can check E into E transpose. When do we say that a matrix A is orthogonal? A into A transpose is equal to I. This is satisfied. Okay, and I will give some other note point based on the orthogonal matrix after the few problems. Okay, since E into F is equal to G. What is this G? Identity matrix. Okay. So I have given in properties, in the definition I determinant inverse. After that, A into B is equal to I, B into A, then B is equal to A inverse and A is equal to P inverse. Okay, so from this, because we require F only, so I can send that E into other side. Because of other side is identity matrix, this E becomes a reciprocal of E, that is E inverse. Okay. So, which implies F is equal to E transpose. Instead of finding inverse, transpose is easy because of orthogonal matrix. Since E is orthogonal, therefore E inverse is nothing but, look at the definitions which is given by me, okay, which are given by me. So, because transpose is easy rather than inverse, so transpose of this matrix, cos theta sin theta 0 minus sin theta cos theta 0 0 0 1. This is the procedure. Just you identify this is orthogonal by checking bar, by verifying E into E transpose is equal to I. You can write this reason also. See, definition regarding orthogonal matrix. Two vectors, vectors means either rows or columns, or you can say in vector algebra also, x1 x2 are said to be orthogonal if each is non-zero. That means each is non-zero vector. That means at least one element in the vector or row or column is non-zero, and dot product, that is x1 into x2 transpose, or depending on the order, either row or column. Vector means either row or column. Depending on that, you check this expression, x1 transpose into x2 is equal to O. So dot product, you know how to find dot product, corresponding elements to be multiplied. For example, see this one, first column, second column. I am considering two vectors. How to multiply dot product? That is x1 into x2 transpose, or this condition, correspondingly multiplied and then adding cos theta into sin theta, cos theta sin theta, plus minus sin theta into cos theta, which are cancelled, plus 0 into 0. So these two columns are orthogonal, each is non-zero. Like this second column, third column, this into this 0, plus this into this 0, plus this into this 0. So which is given 0. Similarly, you can check this first and last column, cos theta into 0 0, minus sin theta into 0, plus 0 into 1 0. So all the columns in this, similarly rows also in this matrix are orthogonal, each is non-zero. Okay. Similarly, three vectors x1, x2, x3 are called orthogonal if each is non-zero and pairwise orthogonal. That is x1 comma x2, x2 comma x3, x3 comma x1 are orthogonal. That means pairwise, taking two at a time, columns or rows, okay, with satisfying dot product equal to 0 as above and each is non-zero, that is called three vectors are orthogonal. Vectors, that means rows or columns, are said to be orthonormal if they are orthogonal and length of each vector is unity. Just comparing this vector algebra, you know how to find dot product between two vectors. You know how to find length of a vector, square root of sum of the squares of the elements. Take any row or column. How to find the length of a vector? Square root of sum of the squares. For example, take first column. What are squares? Cos square plus minus sin theta whole square plus 0 square. How much it gives? 1. And then find square root. Square root 1 is 1. Okay. So here I am giving the length of a vector x is denoted by this symbol. And normalized, that is unit vector, other name is normalized vector, is x divided by, how to find unit vector in the given direction? The given direction divided by its length, that is called. In vector algebra I am comparing. Okay. So how to find this one? I am sure. If x is equal to either row vector or column vector, then length, this is also called magnitude or norm, length or norm of a vector x is equal to square root of sum of the squares a square plus b square c square. This is the procedure for length or norm and then normalized vector. So the purpose of this definitions is which are useful in saying an orthogonal matrix. That means in an orthogonal matrix all the rows or columns are always orthonormal. That means orthonormal means dot product 0 and length of each row or each column is 1. Orthogonal means dot product 0. Regarding rows and columns I am telling. This is a very important point. In an orthogonal matrix, in any orthogonal matrix, comma, the vectors, that means that is rows slash columns are always orthonormal. Underline. What is orthonormal? Dot product of two columns or two rows, any two rows, two columns, zeros, and length of each column or each row is 1. That is, the two conditions satisfied is called orthonormal rows or orthonormal columns, combinedly called as orthonormal vectors. That is, which is true in any orthogonal matrix. So for 2 to 3 problems we have done, and standard orthogonal matrix I have given. Check these things correct or not. Okay. So what is well known? The 2 by 2 matrix, orthogonal matrix I have given cos theta minus sin theta, cos theta. Only 2 rows, 2 columns. So how to find dot product of 2 columns or 2 rows? Correspondingly multiplied and then adding. Cos into minus sin plus sin into cos gives 0. Similarly, row wise, cos into sin plus minus sin into cos gives 0. Length of each column, root over cos square theta plus sin square theta, 1. Similarly, this column, root over minus sin theta whole square plus cos square theta gives 1. Similarly, you can check row wise. That is called orthonormal vectors, which is true for any orthogonal matrix. Now I am giving 3 note points. Please check at home this is correct or not. Okay. The number of distinct elements, that is different elements, in a symmetric matrix order n is at most, this is first point, I am giving in the fill in the blanks along with answer, n times n plus 1 divided by 2. Please check this is correct or not. 2. The number of distinct elements in a skew symmetric matrix of order n is at the most or almost at most n square minus n plus 1. Please check this one. Later, take any 2 by 2, 3 by 3 skew symmetric, symmetric. This is maximum number of different elements. At most means maximum number of them. Next one is the number of algebraic terms in the expansion of a determinant in the expansion of the determinant of a square matrix of order n is n factorial. That is, while expanding a 2 by 2 determinant, how many number of terms in the expanding before the last step, that is simplifying, 2 factorial 2 by 2 matrix, 3 by 3 matrix, you will getting 6 terms, that is 3 factorial. Please check. Okay, or I will show you one example. Similarly, you check for 3 by 3 matrix. A is equal to A, B, C, D. Then determinant A is how much? AD minus BC. That is, it gives 2 terms. That is 2 factorial. Similarly, in the 3 by 3 general expansion determinant, which gives 6 terms, 3 factorial. Like that. You verify this one. In fact. So now we are entering into the main topic, which is depends completely on one chapter, that is solving system of linear equations, all these things. Please take care about this fundamental, basic, entirely depends on so many problems. Rank of a matrix. A matrix A m cross n. Okay. A non-negative integer, say R, is said to be rank of a matrix A m cross n, comma, if first condition there exists at least one non-zero minor of order R. Second condition, every minor of order R plus 1 or more is 0. Is it a handbrake? That is, it is of the highest order non-singular square submatrix of A. I will explain.